Hello, welcome back to section 2 of the course called Hands-on Artificial Intelligence with Python and Keras. My name is Sandipan Das and I will be the instructor for the course for this section. So in this section, we'll learn about deep learning, convolutional neural networks, and we'll test our models in an autonomous driving simulator. What exactly is deep learning and how do we go about that? But before that, where exactly in our learning we'll see or recap that thing. In section 1, you did the introductory part and you did your environment setup, which we will use for our driving simulator. And here we'll first go through the deep learning part, and we will cover convolutional, the theory part of it, and then we'll go to the driving simulator, and we'll use a Keras model to drive our vehicle autonomously in the simulator. But what exactly is deep learning? Before going to deep learning, we'll come to machine learning because it's a kind of subfield of it. So machine learning tries to solve a practical problem by collecting your dataset algorithmically and building a statistical model on the dataset to solve the problem. So I will give an example very soon, but if we see the subfields or the parts of machine learning, it covers supervised, unsupervised, semi-supervised, and reinforcement learning. In supervised learning, you have regression and classification. Basically, in supervised learning, you are trying to find out what kind of data sets your belongs to which class. Let's say you have a function mapping which you have learned through the machine learning, and given an input data set, you try to find out what kind of output class this data or data set is belonging to. So that is supervised learning. So you have to build your model in the beginning, and then you have to train your model with some known data sets, and then you try to find out for the unknown data sets what exactly this model is or what exactly this data is belonging to. So this comes with two variants, regression and classification. Regression is for continuous variables and classification is for discrete value input labels. And in unsupervised, you try to do clustering where you don't have formal definition of what kind of classes the data sets belongs to. So you try to find out similarities in between your data and try to form some false clusters. So that is unsupervised learning. Semi-supervised is basically a mix of both supervised and unsupervised. And finally, reinforcement learning, where you try to find out the policy or what kind of optimal policy is good for your input sequence. So what is the next output sequence or the next sequence in the set of sequences for which your policy is optimized? So that is reinforcement learning. So for supervised, there are some algorithms like k-nearest neighbors, naive Bayes, decision trees, and SVMs, and of course neural network. This also comes under supervised learning. In unsupervised learning, you have algorithms like k-means, k-mean clustering, and association rules. And in reinforcement learning, you have algorithms like deep adversarial networks and Q-learning kind of networks, where you try to learn the policy for which the reward is maximum. But what exactly is deep learning and where it is coming from? So machine learning tries to find out a higher dimensional representation of your data set through which you can model a particular feature. So deep learning is basically forming that higher dimensional representation with much more nodes in between the input and the output layers. So how exactly it is, or what exactly it is? So I will go to this site called playground.tensorflow.org, where I have done some interesting visualizations of this high dimensional data. You can also try it. So I have two input features, x1 and x2, and on the left hand side I have my data. So I would like to find out the clusters out of it, and the yellow belonging to a particular cluster and the blue belonging to a particular cluster. So I run my machine learning algorithm, and I try to find out what is the training loss on this data. So you see that the input and the output, there is no hidden layers in between it, and basically it is not able to find out or segregate the data in a meaningful way, so that this data clustering is possible. So I will stop it in a while because it is not converging. So now what I will do, I will use the same input features, but I will add 3 hidden layers in between. The first 2 layers having 4 neurons each, and the last one having 2 neurons. So 3 hidden layers. So what I will try to do is try to learn if with this kind of representation, the model can learn something meaningful. And I'm using L1 regularization. So let's see. So the test loss is coming to 0.49, and it is decreasing, and the training loss is also decreasing. And you see that some kind of cluster is forming out of your data. So how exactly this higher dimensional model looks, I will come very soon. I will show you some representation of this higher dimensional model. But as you see that your data is clustered quite well in this kind of model representation. So now I go to the L2 regularization, where it tries to remove this overfitting problem. And here also you see that the cluster is forming quite good, and the data sets which are misclassified, the boundary is going towards those parts, and it's trying to classify in a decent way the data which we had. And the training loss is decreasing, and it is almost, yeah, it's quite a decent training loss. And you see that it has run for like 900 epochs or something. So as I was saying, I was trying to represent like what is exactly the higher dimensional representation of this model. So first I tried to do the same model which I was using over here. And by the way, the one which I'm going to show is called cognate.js. This was developed by Andrei Karpathy during his PhD, and he tried to show the visual representation of higher dimensions. So by clicking the change network, it is trying to initialize the network from the very beginning, and it is trying to show what are the different higher dimensionals representation of the data in the different layers. So I will do change network once more, and as you see that the points are also classified or clustered, and you see that in the different layers how the higher dimensional model looks. So it's basically warping of the data in such a way that you can segregate the data. So it's kind of a kernel trick on top of SVM, where you can separate out the data using some kind of planes. So that is exactly happening in this deep neural networks, where the models in between are creating a higher dimensional representation of your feature vector in such a way that you can segregate the data. And see, on the last layer, you can actually have a plane in between which can segregate the data. So this is kind of what is happening. And the basis functions or the activation functions which I have is tanh, which is trying to represent or mold the data in such a way that at the last layer you reach at a point that you can segregate the data quite well. So that is basically it. That's basically what is happening in deep learning, where you have multiple layers in between which can create a higher dimensional feature representation of your data, which is helpful for segregating it.